Hello, we're Team Extra-Leaded Solder, and this is our UAH Electrical Engineering Senior Design Project for Spring 2025. Our team has been working on a hand gesture recognition system, and our team includes Tyler Edge, Ian Livingston, Beth Dellinger, Brody Carroll, and myself, Logan Self. We've developed a real-time hand gesture recognition system that uses neural networks and GPU acceleration to process camera input and recognize hand gestures with minimal latency. This means the system can recognize and respond to hand movements nearly instantaneously. It can recognize 7 different gestures: open palm, closed fist, peace sign, pinky finger up, pointing index finger, the OK sign, and a custom gesture with your index finger, pinky, and thumb. These gestures act as commands for drawing or erasing on a built-in LCD display, providing a relatively intuitive and completely touch-free way to interact with the system.
Our system is housed in this custom-designed enclosure, which keeps all components secure while allowing for proper airflow and easy access. The magnetic lid allows quick access to the hardware inside. The system features an ArduCam 1 megapixel camera capable of capturing at 120 frames per second, positioned to provide an optimal field of view for hand tracking. These connect directly to the Jetson board via USB. To maintain optimum performance, we've integrated a 50mm cooling fan that creates a negative pressure inside the enclosure, pulling in air from surrounding vents. This keeps the Jetson module within ideal operating temperatures, even during intensive processing. For the I/O, there are USB ports for peripherals like keyboards and mice, DisplayPort to HDMI connection for the built-in 7-inch display, and a power input via the DC barrel jack. We've also utilized the expansion header pins for custom functionality, including the GPIO pins for the power and reset switches you can see here on the side of the enclosure. The fan is also controlled through the GPIO pins. Additional pins still remain available for future expansions.
Now I'll demonstrate how our system works in real time. As you can see, the 7-inch display shows the camera feed with gesture recognition overlays. When I make an open palm gesture, the system recognizes it immediately and highlights it on the screen. The pointing gesture allows for precise selection. The OK gesture activates drawing mode, and you can see how instantaneous this changes. Here I am using hand gestures to create a simple drawing. This drawing function is remarkably responsive due to the low latency processing of our model. Altogether, this system is capable of capturing and processing over 60 frames per second, making for a very fluid user experience. Our model is a YOLO V10 Nano convolutional neural network model that has been trained on the Hagra V2 dataset. This dataset consists of over 1 million RGB images divided into 33 unique classes. Our initial model was a PyTorch implementation, but after extensive testing, this model utilized 0% of our GPU. This setback converted us onto NVIDIA's ONNX framework and the unrivaled optimization of the TensorRT FP16 model. This change reduced latency from 40 milliseconds to 5.5.
The heart of our system is the NVIDIA Jetson Orin Nano Super GPU, which allows us to run complex neural networks in real time. The system includes Bluetooth, Internet, and standard peripheral connectivity, making it easy to further develop or add models to the system. This flexibility allows for continued improvement and adaptation to new use cases. In closing, our hand gesture recognition system has closely achieved our goal of creating a low latency interface that can process around 60 frames per second with high accuracy. By using GPU parallelization and optimized neural networks, the team has created a system that feels responsive and natural to use. Looking to the future, this technology could be further explored with more efficient transformer models and improved training techniques, with many exciting applications. Thank you for watching.